Now for this problem, I want to take the same region that I had in the last example, but now I want to rotate it around a different axis. Rather than rotating around the x-axis or the y-axis, we're going to have our first example of rotating around a line completely different. So if you remember, this was y equals the square root of x, which was this green curve. Hopefully you're not colorblind. Sorry if you are. It's the top curve. And then the bottom curve is y was equal to x cubed. It's literally the same region as before. So we're taking this region right here, and you're thinking, well, it doesn't look the same. But it is the same. It's just that the scale is different. And the scale is different because here I was only going from -1 to 1 for my y values. But down here, I'm going to go all the way down to negative, well, it looks like -5, because y equals -2 is my axis of rotation. So this line right here is where we're spinning this object. So it's going around and around that axis, that horizontal line. So it's an axis of rotation. It's not the x-axis, but it's the axis of rotation. All right, well, the boundaries are still 0 and 1. That hasn't changed, right? We can still see that the intersections here are 0 and 1, just like before. So this is A and this is B. No problem. All right, now let's look at that rectangle again. So if I take that rectangle from the middle, kind of the same place I did it last time, I can still see that it has to be perpendicular to the axis of rotation. Since it has to be perpendicular, that means it has to be dx as my thickness still. All right, no problem there. Dx is the thickness. Great. The hardest part, as per usual, is finding those radiuses, finding the large radius minus the small radius. Okay, so this distance right here, from the axis of rotation out to the outer edge, because think about how this is rotating. This distance right here is capital R of x. It's from this value of -2 all the way up to that curve. And then the inner axis of rotation, the smaller one, is from the axis of rotation, radius of rotation, the inner radius of rotation is from this blue curve all the way down to the radius, or excuse me, the axis of rotation, That's little r of x. Okay, now how much is that? Well, to get from the axis of rotation just to the x-axis is 2. But to get from the x-axis all the way up to that green curve is square root of x. So this particular one is the square root of x plus 2. Because you go square root of x gets you from the green curve all the way to the x-axis, and 2 will get you from the x-axis down to that axis of rotation. That's a distance of 2. And then for the inner radius of rotation, it would be 2 again, plus, right, because 2 will get you from here to here, right, to back to the x-axis. And then that little bit left over is the square root of x. Oh, not the square root of x, it's x cubed. Sorry, I was looking at the square root of x when I said that. So it's x cubed. The inner function, that little blue one right there. All right, wonderful. So that means that I can find my volume, right? The volume is equal to I'll move it up. All right, pi integral. So remember what it is. It's r of x squared minus little r of x squared, right? That part hasn't changed. And also what hasn't changed is 0 to 1, because we're still going from x equals 0 to x equals 1, intersection point to intersection point. All right, so I need capital R of x squared minus little r of x squared. And I definitely know it's dx. I know that right away. Once I know my axis of rotation is horizontal, that means it has to be dx because it has to be perpendicular. That rectangle, excuse me, has to be perpendicular to that axis of rotation. All right, so capital R of x, again, was the square root of x plus 2. 2 to get me to the x-axis, square root of x to get me to the top part. This bit is x cubed plus 2. Right? That's little r of x. And now I just have to work it all out. So this is pi times the integral 0 to 1. I need to FOIL this, right? Distribute it in my head. So square root of x times square root of x is x, plus 4 square root of x plus 4, minus, just doing a little bit of algebra here. And again, I'm going to take this binomial and square it. So x cubed times x cubed is x to the 6 plus another 4x cubed plus 4 dx. Well, hopefully you're thinking what I'm thinking, and some of this stuff goes together. So 0 to 1, I'm going to have, well, an x of 4 square root of x. I don't have to worry about the 4's because this is plus 4 and this is minus 4, so those are gone. So it's just x plus the square root of, or excuse me, x plus 4 square root of x minus x to the 6 minus 4x cubed dx, which is 1/2 x squared plus 4 times, okay, this is x to the half here. So that'd be x to the 3/2 times 2/3, right? We add 1 to the power and then multiply by the reciprocal of that power, aka we divide. Minus x to the 7th times 1/7, minus 4 times x to the 4th times 1/4. So that one's actually going to go away because 4 and a 4th are going to cancel. Divide to 1. And then we're going to take this from 0 to 1. Well, luckily the 0 is irrelevant because 0 would make all of these terms 0. So that's kind of not important. So it's 1/2 plus 8/3 minus 1/7 minus 1. And then we would use Desmos, right? This is what Desmos is good for. So we would find that in Desmos. Right? There's the axis of rotation, and I have the integral calculations right down here. And it's 8 pi over 42. It's 85 over 42 if you want to see the fraction part, because the pi just makes it become irrational. So it's 85 pi over 2. Again, it's centimeters, so centimeters cubed, which is all about 6.358 centimeters cubed.